Today we are doing a question that's going to pop up on every single story problem free response question that you see. Okay? If they describe something in a story problem type setting, you are going to have this question on there. I guarantee it. Every single time this type of question is on there. Today we're going to focus on using calculators just to make the process easier, but more than anything today it's about setup. Okay? A cup of tea is cooling in a room that has a constant temperature of 70 degrees Fahrenheit. This is one time that they gave you extra information you don't need. We don't need that 70. Okay, very rarely do they do that on the AP exam. Here they did. If the initial temperature of the tea at 0 minutes is 200 degrees, and the temperature of the tea changes at the rate of R of t degrees Fahrenheit per minute, what is the temperature to the nearest degree of the tea after 4 minutes? So the first thing I would always suggest you do is look at what they told you and figure out what it is. So in this case, it's R of t. What is R of t? It is a rate. R of t is equal to a rate. R of t is a rate. That's an important thing to understand. They gave me a rate. What are they asking for in the end? A temperature. So this is a rate of temperature, but in the end, they just want to know what is the temperature. What are we going to have to do with a rate to make it just tell me temperature? Integrate it. We are going to integrate a rate. If I integrate a rate, it will tell me an amount. If I integrate a rate, it tells me an amount. From when until when do I want to integrate this rate? 0 to 4. I want to integrate this from 0 to 4. What does that tell me if I integrate this rate from 0 to 4? That tells me what? This is the change in temperature in degrees Fahrenheit from 0 to 4. That's what it's telling me. But most importantly, it's the change. That's what it's telling me. This is a change. Okay? So let's type that into my calculator. So if I'm typing this into my calculator, I would go to Y1 always. I always like to type it as Y1 in case I have to type it in again. But if I type this thing in, it says negative 6.89 e to the negative 0.053 t, in this case x. That's my equation. Second quit. I'm going to integrate that thing. So I'm going math 9. Remember, math 9 is going to get me integration. I'm integrating this thing from 0 to 4. Remember, if your calculator dies, there's a good calculator app on iOS on Apple called Calculator 84 or Calculate 84. That would be a good thing to download in case you don't have your calculator with you. You're integrating that function. So in this case, I'm just going to go alpha F4 and pick Y1. And then dx. I hit enter. Boom. There is my answer. Negative 24.834. So I got negative 24.8 something. Is that the answer to my question? No, none of those say anything near negative 24. Why? What else do I need to do to figure out the temperature of the tea? Austin? You have to figure out what you started with. 200 was my starting temperature. I started at 200. And then I'm going to add to that the change. And if we put those together, start plus change, that is going to tell me the ending amount. That is the phrase we're going to use all day today. Start plus change equals end. Where did you start? How much did it change? That's what I ended with. In this case, 200 minus 24 is 175. Obviously, it's minus in this case because it's a cooling temperature, but that's where I got 175 from. Questions on that one? All right, here we go. We're talking about displacement. We talked about this in first semester. Displacement is the change. Okay, it's the integral. Okay, specifically, it's going to be the change in position, but we're going to use it and more context for everything. Okay, it's the change of that amount. Okay, it can be positive, it can be negative, it can be zero. It's where you ended minus where you started. Okay, it's the difference between your starting and your ending amount. To do displacement, we can often just integrate. Okay, if I want to find the change in position, you integrate velocity and it tells you the change in position. Okay, if you want to find your new position, okay, the ending position, the end. It doesn't always the actual end, but it's the new position. You take your start plus your change. Start plus change equals end. That's the phrase of the day. Every single story problem you have on the free response portion of the test is going to have one of these built in there somewhere. The other thing we have is total distance. Okay, total distance. So if I were working on this line and I started here and I went up to 2 and then back to here and then back to 2, I started here, I ended here. The displacement is 2. What would my total distance traveled be? Is 8. I went forward 2, back 3, so I'm at 5, and then forward 3, I'm at 8. It's the distance actually traveled. That's an important phrase for the day as well. To find the total distance traveled, it is the absolute value of velocity. Okay, I don't care if it's positive or negative. I just want to know the absolute value of velocity, and then we integrate that. It'll make more sense as we do it later on. Let's try it here. Number 1 says a particle moves along a horizontal axis and has this velocity, where v of t is measured in meters per second. What is the particle's displacement during the first 4 seconds? What do I need to do in order to find displacement during the first 4 seconds? Integrate from when to when? 0 to 4. I'm going to integrate velocity. Do that. Type that into your calculator, get an answer. When I type stuff in, I like to not make mistakes. So as I type it in, I'm typing in x squared minus. I always use the fraction button. So I'm going alpha f1 n over d, and then I can type it in the way I want. 8 over t plus 1 squared. So parentheses x plus 1, close it, squared. You don't have to use the fraction button, but you're not going to make a mistake if you use the fraction button. And if you don't, there's a chance that you will. Okay, so I suggest using the fraction button. Everybody good to typing in that? And then we're just doing it. We are going math 9. I am integrating from 0 until 4, correct? Alpha f4, y1, d, x, enter. Boom, there's my answer. How many decimals should I round to?
3.
14.933. It does not. It is always 3. Get out of here with your significant figure. Then we don't care. How far did the particle travel during the first 4 seconds? Okay. How far did it travel total during the first 4 seconds? To better understand that question, let's look at the graph. You don't have to do this on your calculator, but just look at my screen. Okay. There is the graph of this. We found the area under the curve. So if I did this problem at the beginning, it's not going to like that. If I found the area under the curve here, it would take this value right here, and it would take all of this, right? This would be positive, this would be negative, and so that's where I got 14 from, okay? This is significantly larger than that. It got me 14. It told me the change, but that's not the question, okay? The question I want to know is the total distance traveled. Luke? Okay. So what we need to do is make this thing be positive. So I'm giving you a random number. Let's say this was 8 and this was 22. Right now we did 22 and this was 8, so it was negative 8 plus 22. I don't want that to happen. I want it to all be counted. So the way that we do that is we're going to do the absolute value. Again, you don't have to do this in your calculator. Just watch them. Okay? So what I'm going to do is I'm going to go alpha F2, absolute value of Y1. And understand what doing the absolute value of that does. Look at my graph. it takes this little part that was below and puts it up above. It does the absolute value of it. It brings it to the top. So when I when I figure out the number here, I'm going to integrate math 9. I want to know total distance traveled. So I'm going from 0 to 4. And then we're going to use absolute value. So find the absolute value button in your calculator. There's a lot of different ways to do it. The way I do it is alpha F2. Alpha F2, this button right here. Alpha F2 right there, it's ABS. That's the one I'm selecting. I'm going to do the absolute value of my function. So I'm plugging in a Y1 right there. And it's going to be dx. I type it in. I hit enter. It takes a longer time anytime you do absolute values. My answer is 22.520. Does it make sense that it's a bigger number than the displacement? Yeah, it's always going to be the same or bigger. Okay, 22.520. All right. Now let's read this third one. If the initial position of the particle at S is 1 is 9, what is the particle's position at t equals 5? So we know S of 1 is 9, t of 5, or at t, we're trying to figure out what the position is at 5 seconds. Talk with your neighbor for a second. See if you can come up with a plan. What do we think? Anybody have a good idea here? What can we do? We want to find the change. From when to when do we want to know how much the position changed? This time we are going from 1 to 5 because this right here, this S of 1, that's my starting position. Even though it doesn't say it's not at 0, who cares that it's not at 0? That's my start. My start is a position of 9 at 1 second, at t equals 1. I take that number. I'm going to add it to the change from 1 to 5 of v of t dt. And that's going to be all equal to my ending position. So in my calculator, I'm typing that in. 9 plus math 9. I'm integrating this thing from 1 to 5. I'm integrating this equation, y1 dx. I type it in. I hit enter. 47.666 or 47.667. We did not do absolute value because we weren't talking about total distance traveled. I just want to know the change. And so in this case, I'm just integrating that thing without absolute value. This is my answer, and that's in meters. That is what my position is now after 5 seconds. Where did I start? How much did I change? That will tell me my ending amount. That last one is meters. Yes, they're all meters. Questions there? Let's look at number 2. Number 2 says water leaks from a tank at a rate of 2 plus 5t liters per hour. Okay, so we've got a rate here where t is the number of hours after 7 a.m. Pay attention to that. T is the number of hours after 7 a.m. How much water is lost between 9 and 11 a.m.? If the tank had 200 liters at 9 a.m., how much water is in the tank at 11 a.m.? Talk with your neighbor. See if you can set it up. I don't care about you type in your calculator. Just try and do the setup. Go. All right, here we go. Anybody have a setup here? Obviously, we are integrating. We're finding an amount, so I'm integrating the rate. So I'm integrating that 2 plus 5 TDT. Anybody have an idea of when I'm going to integrate this thing from?
2 to 4.
2 to 4. Evan, why 2 to 4?
Start at 7.
Yep.
And 9 minus 7 is 2.
Yeah, 7 is t equals 0. Okay? 7 is t equals 0. That's my starting amount. And so Evan said to get to 9, that's 2 hours after it. And then we're going to 11. That's 4 hours after. This is the change. I want to know what I end with at 11 a.m. Okay? I want to know this number. When does that get me 4? That's my ending amount. So this is the one that goes here. Okay? This one right here is my starting amount. So over here, I've got my start. What's going to go here? 200. That's my start. 200 minus that integral is going to get me my ending amount. Okay? You can type that into your calculator. I'm very confident in your abilities. To save us time, Yes, we are doing minus because it's going to tell you a positive amount. So if we integrated this right here, it would get you 34. So we had to go minus there because it's telling you how much is lost. It is a rate of removal, so we had to go minus sign. Does that make sense? So it's 200 minus 34. The answer is 166 liters. Make sense on that one? Let's do it again. Part 3 says pollution is being removed from a lake at a model rate modeled by this function right here. This is tons per year, where T is the number of years since 2010. If there are 50 tons of pollution in 2020, how much pollution was there in 2010? Just try to do the setup. I'm not super worried about you being able to type in your calculator right this second, but do the setup. Talk with your neighbor. Think about it. It's a little bit different. Here we go. Let's look. We start off with this thing. They told me an equation. That equation is a rate. It's telling me tons per year. What do I need to do with that rate to tell me just tons? Integrate it. I'm integrating this rate, 20 e to the negative 0.5 t dt. Now here's the tougher part. When am I integrating this thing from? We're going from 0 to 10 because t is the number of years since 2010. So we're starting at 0 and we're going to 2020. I'm going to integrate that thing. This is my change. Start plus change equals end. Now, the difference here is we are doing removing this. This is the rate, this is the amount removed, so it's going to be start minus change equals end. What else can I plug in here? What is 50? The end. Why the end there, Cannon? Yes. This number right here, that top number, is the ending amount. So I'm ending in that year with the 10, that represents the 10. That's 2020. So we're going to end with 50. I need to figure out this guy. So in your calculator, it's like taking 50, and then you can move this thing to the other side to be 50 plus that to get me my answer. Does that make sense how that works? Flip it over to the backside. We've done them with a calculator so far. Now we're going to do it without a calculator. This takes a little bit more work. Pay attention, please. The function v of t is velocity from negative 2 to 3. Determine when the particle is moving to the left, the right, and stopped. They told me velocity, and they want to know when the particle is moving left, right, and stopped. What do I need to do with this equation to tell me when it moved left, right, and stopped? What do you need to know about velocity to know when you go left, right, or stopped? When it changes sign. When is it stopped? What's going to be true about the velocity if it's stopped? It's 0. So I really want to know when v of t is 0. This isn't what we're doing today. It's what we've done in the past. You got to be able to make that connection all the time. V of t equals 0 means it stopped. Well, they told me v of t. I want to know when it's 0. When is t going to be equal to 0? At plus or minus 1. That is when velocity is 0. Great, I need to know that. But I also want to know when velocity is positive or negative. How could I figure out when velocity is, or when I'm moving left or right? What would I need to do next? Number line, sign chart. For me to figure out if I'm going left, right, or stopped, I want to know what the signs are of my velocity. Because if velocity is positive, I'm moving right. If velocity is negative, I'm moving left. If velocity is 0, I'm stopped. So I'm going to throw these two numbers on here, negative 1 and 1. On a normal day, I'd give you time to do that, but we're kind of running behind, so let's go. So velocity, I'm taking these numbers, I'm plugging in. What's a good number to plug in? 0. If I plug in 0, I'm plugging it into velocity. It's going to be negative because it's 0 squared minus 1. If I plug in 2, it would be positive. If I plug in a number here, it's going to be positive as well. So when is the particle moving left? Negative 1 to 1, because that's when velocity is negative. I am moving right when velocity is positive. So that's negative 2 to negative 1 and 1 to 3. And then obviously I'm stopped when t is equal to plus or minus 1. That's a question I could have asked you back in October, and you would have been fine. Okay, don't let that be weird to you now when we throw it in with a new chapter. Okay, we're focusing on movement here. Questions on A. Question B says find the particle's displacement for the given interval. So displacement means the change in position. They told me velocity, and I want to know the change in position. What do I need to do to find the change in position? Integrate velocity from when to when. Do that without using your calculator. You can do it. Set it up. We are integrating, so I got to find the antiderivative. The antiderivative of t squared minus 1 is 1/3 t cubed minus t. Then I plug in upper bound, so it's 1/3 3 cubed minus 3 minus lower bound. So 1/3 times -2 cubed minus -2. Obviously, if you did that, it'd be wrong. What did I forget? Parentheses. We could work this out, but I don't really want to. A lot of you on your free response lost points because you did some math that you thought you could do and you couldn't get there. Anybody get an answer for that? What'd you get, Dylan? 6 2/3. Okay. Good. We got backed up there. So 6 2/3. We didn't have to do it, though. Let's go to the last one. And this is important because I didn't get to this the other day in notes, and I need you to understand it. Find the total distance traveled. Total distance traveled. What are we doing when you see the phrase total distance traveled? If I'm just setting this up, it is the absolute value of the integral from -2 to 3 v of t dt. Absolute valued. That is total distance traveled. Because velocity is positive, it's going to the right. If velocity is negative, it's going backwards. But I still want to count that velocity. Without a calculator, this is difficult. Okay? The best way to understand what's going on here is think about this graph. It is a parabola that has been shifted down 1. Okay? My graph would look something like that. It's just a parabola. It's been shifted down 1. We are integrating this thing starting at -2. So we would have this right here, then you would have this right here, and then you would have this right here. I want to find the area under the curve. I want to take this plus that plus that. I want to add up all of those numbers. Everybody understand what I'm doing? So to do that, you can't integrate it at once, because if you integrate it at once, it's just going to tell you the change. Instead, I have to split this up into separate integrals. From when to when should I make my first integral? -2 until -1, because that is when that gets me 0. We did that up here. Okay? From -2 to 1, v of t dt, I need to integrate that thing. When I do that, is it going to get me a positive or negative answer? Positive, because it's an area above the curve. So that's pretty easy. But that's not it. I need to take that answer, and I'm going to have to add to that another integral. What am I going to have? What's my second integral going to be from? -1 to +1. V of t dt. What's going to be true when I do that part? It's going to be negative. So I have to do something. What could I do to show what the right answer is? You could do the absolute value. Now, in this case, it would be the absolute value on the outside. We don't know how to do absolute value on the inside. But on the outside, it's easy. Basically meaning take whatever that number is and make it positive. Okay? Or if you want to go crazy, you could say, hey, I know it's going to be negative, so minus the negative, it would get you positive as well. Either way is fine. But that's not enough. I got to keep going. My last integral is going to go from 1 until 3 v of t dt. I could do that by hand. It would not be fun. Often they'll just say set it up. One year they made it a multiple choice question. And me, who's good at it, took me about 10 minutes to do it. Okay? It's not easy, but you could do it. Do you understand why we had to split that up? We had positive velocity and negative. Some of it was above, some of it was below. That is why we had to make that switch. Okay? Look at one last problem here. See what you can do on that story problem with your neighbors. See which one is the correct answer. On number 5, the bell rang, so we didn't finish. We don't care about the starting position. since it's asking about total distance traveled, I don't care where we started. If I ran 10 miles in Mexico, it doesn't matter that I was in Mexico to run it. It was just the fact that I did it. So position, I don't care about if I'm doing total distance. This right here is not going to get you what you want. Okay, you think it is, but to do what we needed, that absolute value needs to be on the inside. So E would be okay here, but what we really want is this guy right here. Okay, we want letter C because I want to integrate it from 2 to 5 and then from 0 to 2. Since from 0 to 2 it's increasing. No, I'm sorry, it is going to be E. It is E. Because if we're going from 0 to 2, it needs to be positive. This one is going to get you the opposite of what you want. Because since from 2 to 5, it is decreasing. This is negative, and then you would have more negative. This would get you the negative answer that you want. The correct answer you want there is E.